7-16. And we'll look at 7-15, which again is the same. They're expressed a little bit differently, so use the words of one to fit the other, and I think you'll make this thing work. But 15 says a recent study of hourly wages of maintenance crew members for major airlines showed that the mean hourly salary was $20.50 with a standard deviation of $3.50. Okay, assume the distribution of hourly wages follows the normal probability distribution. If we select a crew member at random, what is the probability the crew member earns between $20.50 and $24? Okay, in this case, I'm sorry I did the math pretty easily and quickly, that my z is going to be equal to 1, right? Because I'm one standard deviation from the mean, right? $24 would simply be one standard deviation. So my z is that, and again, I want to know what the probability is, and I can come to this handy tool. I can come down first and look at this. If I have a z of 1, it's 34%, and so and I want to know between the mean, right, of $20.50 and that $24, okay, and so in this case it is the 34.13%, and I can take a look at the deal up here too, again, so I just come right here to the 1, it's going to give me the same answer, if I can get there, 34.13%. Okay, so then onward, mine says more than $24 an hour. Okay, well this gets to be a little more. I don't think it might do it on this one. Yeah, it does. Okay, so I can z onwards. I can come down to the 1, and maybe I can. There we go. 15.87%. Right. It's just it's not really the reciprocal, because reciprocal you take -1, but from the mean then, right, it's 15.87%, which I have there, okay, but it's simply the mean minus that then, right, because I looked at the mean to $24, now I'm talking about over $24, and so I can simply say that this is equal to 0.5 minus that. Okay, and that gives me 15.87%. Okay, and then lastly, mine says less than $19 per hour. Okay, well now I got to do a little bit of math. Okay, and I use that normal distribution thing, but I'm going to show you guys the math way to do it. So again, I've got that it's equal to my n, which is my 19, minus my mean, divided by my standard deviation. And I come up with minus 0.42. Wow, that's kind of an oddball number, isn't it? Minus 0.42857. Okay, well, let's go find that then in my z. Oops. So 0.42, was it 0.4289? So I'm going to be closer to 0.43 or 16.64. Okay, but we have to kind of look at that and say, well, that's the number from the mean, right? Which was z was 0.42 something. It's closer to 0.43, wasn't it? So 16.64. But again, I'm looking at the ones that are up to that. And so if I took 0.5 minus that, I'm going to end up with about 30. What the heck is that? About 34. Okay. I could also do it again this way and come up to that 0.43. Is that what I said? Oopsie. So about 33.36%, somewhere's in that neighborhood. Okay, and I'm close there, 0.33. Okay, I did in this case, and you could do it in this case, normal distribution. Okay, and how do I do a normal distribution, and what's that tell me? The normal distribution always starts at 0. Okay, so if I'm looking at this chart, okay, it's always, I'm sorry, it doesn't start at 0. It starts over here on the left-hand side. Okay, the z down to whatever. Technically, in these things, the chart goes to infinity. These lines never touch technically, but practically they're, so close at this point that it doesn't matter. Okay, and so when I do a normal distribution, I'm always starting from down here and calculating all the way up to here, right? And so I have to keep that in mind, and for this particular one it works fine. So how do I do that normal distribution? I'll see if I can replicate that thing. I haven't done normal distributions for a while, so let's go to stats, alphabetical. Again, you could type it in, it'd probably be faster. Normal distribution returns the normal. Yep. Okay, so I've got my x. In this case, my x is 19, right? My mean, I know to be that. My standard deviation, I know to be that. And then do I want it to be cumulative? Okay, I use 1 if I want it to be cumulative. If not, I use a 0. Let's just see what I'm not sure what the other answer would be. Obviously, the 1 gives me the correct answer, the 0.3341. Okay, and a 2 gives me the same thing in this case. Okay, I can't remember what the difference is there. We'll probably get into that later. Okay, but in this case, it gives me the correct answer. I'm pretty sure that 1 is the number that we wanted to use, or the true for that particular case, and that gives me the right answer. Again, when I looked it up, I was a little bit off because my z value, I could only use 0.43. I couldn't get her that far. Okay, and this is technically using a z value that's extended out to all those decimals.